Let's practice multiplying and dividing integers and decimals together. For questions 1 through 4, let's go ahead and find the product for the given integers. So just keep in mind that when we're talking about product, that we're actually finding the answer to a multiplication problem. All right, so just make sure we know that vocabulary. So the parentheses means multiplication. And let's go ahead and show our calculations and make sure we can use the standard algorithm pretty effectively as well. All right, so for number 1, we have 542 multiplied by negative 59. All right, so we'll take our factor that has more digits, this 542, and multiply it by the 59. Let's go ahead and just ignore the negative for now. Okay, we'll deal with that in just a moment. And let's go ahead and start with this 9 here. So 9 times the 2 is going to be 18, carry the 1. Then we have 36 plus 1 is going to be 37, carry the 3. Then we have 45 plus 3, which is going to be 48. So that's our first partial product. Our second partial product is going to be this 5 multiplying by that 542, which is really 50. So 5 times 2, that's going to be 10, carry the 1. Then we have 20 plus 1, which is going to be 21, carry the 2. Then we have 25 plus 2, which is going to be 27. All right, if we go ahead and add these two partial products together here, let's see what we get. We're going to have an 8, a 7, a 9, 11, carry the 1, and we have a 3. Now, keep in mind that we had a positive times a negative, so it's going to be the opposite of this. So it's going to be negative 31,978. All right, let's check out number 2. For number 2, we have another multiplication problem here. Again, we're finding the product. Let's go ahead and ignore the negatives for now and just take this 93 and multiply it by 48. Let's go ahead and start with the 8 here. So the 8 multiplied by the 3 is going to be 24. We'll put the 4, carry the 2. Then we have 72 plus 2, which is going to be 74. All right, that's our first partial product. For our second partial product, we have this 4, which is really 40, right? 4 times 3 is going to be 12, carry the 1. Then we have 36 plus 1, which is going to be 37. So if we go ahead and add these two partial products together here, we're going to get 4, 6, 14, carry the 1. Then we have a 4. So we have 4,464, but keep in mind that we have one negative in the problem, so it's going to be the opposite of that. So negative 4,464. For number 3, let's see what we got here. We have a negative multiplied by a negative, so we're going to ignore two negatives here, or the opposite of the opposite. So just like in the last couple examples, let's go ahead and ignore the negatives. We'll deal with them afterwards. Let's just go ahead and look at the absolute values here. So we'll start with this 7 times 94, so 7 times 4, 28, carry the 2. Then we have 63 plus 2, which is going to be 65. Next, let's deal with this 3, which is really 30, right? So 3 times 4 is going to be 12, carry the 1. And then we're going to have 27 plus 1, which is going to be 28. Now let's go ahead and find the second partial product here. So this 3 is really 30. 3 times 4 is going to be 12, carry the 1. Then we have 27 plus 1, which is going to be 28. If we go ahead and add these two partial products together here, we're going to have an 8, a 7, a 14, carry the 1, and we have a 3 over here. Now keep in mind, we did have two negatives in the problem, so the answer should be the opposite of whatever we got for our product. So the opposite of 3,478 is just going to be 3,478. All right, let's check out number 4 here. For number 4, we have a negative multiplied by a positive. Again, let's go ahead and just ignore the negatives for now. There's only one of them, so it should be the opposite of whatever answer we get. So 23 times 48, they both have the same number of digits, so it doesn't matter which one goes on top. Let's go ahead and start with this 8 here. 8 times 3 is going to be 24, carry the 2. Then we have 16 plus 2, which is going to be 18. All right, that's our first partial product. For our second one, let's see here. 4 times 3 is going to be 12, carry the 1. Then we have 8 plus 1, which is going to be 9. All right, if we go ahead and find the sum of our two partial products here, we're going to get a 4. This is going to be 10, carry the 1. This is going to be 11. So we're looking at 1,104, but keep in mind we had one opposite in here. So it's going to be the opposite of whatever product we got. So it's negative 1,104. All right, so there you have 4 different practice problems on multiplying some integers together. And let's go ahead and try some finding some quotients now. So in questions 5 through 8, we're going to go ahead and find the quotient of these numbers. The quotient means the answer to a division problem. And again, let's go ahead and make sure we show our calculations practicing the standard algorithm for division this time. For number 5, we have a negative divided by a negative, but again, let's just ignore these negative signs for now, or just rather take the absolute value of each number and calculate. All right, so setting up this standard algorithm here, let's go ahead and put the 762, the dividend, inside this house, the divisor outside to the left here. 3 into the 7 is going to be 2 times. Let's go ahead and put 2. 2 times 3 is going to be 6. Let's see how much we were off by here. 7 minus 6 is going to be 1. Let's go ahead and bring down this 6 here, so it's going to be 16. Now 3 into 16 is going to be 5. 5 times 3 is 15. If we go ahead and find the difference here, this is going to be 1. Let's go ahead and bring down this 2 and repeat the process again. Now 3 into 12, let's go ahead and say that's going to be 4 times, right? So 4 times 3 is going to be 12. And we can see here that we have a remainder of 0, so it went in evenly. So we have a quotient here of 254, and the answer here is going to be positive because we should have the opposite of 254, which is just 254. For number 6, we have another division problem here. Let's find the quotient. So let's go ahead and set this one up. We're going to take this dividend of 648, take the absolute value, and take the absolute value of 4, negative 4, which is 4, and go ahead and just divide here, right? So 4 into 6 is going to be 1 time. 1 times 4 is 4. If we go ahead and see how far we were off by, make sure this is less than 4. So 6 minus 4 is 2. That's definitely less than 4. Let's go ahead and bring down this 4 and repeat the process. 4 into 24 is 6 times. 6 times 4 is exactly 24. So when we subtract here, we should get 0. Let's go ahead and bring down this 8 here and repeat the process one more time. So 4 into 8 is going to be exactly 2 times, right? So 2 times 4 is going to be 8. And if we go ahead and subtract here, you can see we're going to get a remainder here of 0. So our quotient here is going to be 162. But ask yourself what the sign is supposed to be. So we had 1 negative in the problem, which means we need the opposite of whatever quotient we got. So negative 162. For number 7, we have another quotient. This one, it looks a little shorter though, this problem in general, because we have a 2-digit. We have 98 divided by 7. So take the absolute values and just go ahead and perform long division here. So 7 into 9 is going to be 1. 1 times 7 is going to be 7. I guess this one's not really long division. It's maybe just more like short division maybe. So 9 minus 7 is 2. Let's go ahead and bring down this 8. This is going to be 28. 7 into 28 is going to be 4. 4 times 7 is 28. And we see here we have a remainder here of 0. So our quotient here is going to be 14. But then ask yourself about the negatives, right? So we have 1 negative in the problem, so we should have the opposite of 14, which is negative 14. All right, one more quotient problem over here. For number 8, looks like we have 396. Take the absolute value of that, which is just 396. And then we have negative 6, but we'll take the absolute value for now. So that's just going to be 6. And let's just use our standard algorithm as we normally do. So 6 won't fit into 3, but 6 will fit into 39 6 times. So 6 times 6 is 36. We go ahead and see how far we are off by. So it looks like that's going to be 3. And we're going to go ahead and bring down the 6 here and repeat the process. 6 into 36 is going to be 6 times. 6 times 6 is exactly 36. We have here a remainder of 0. So our quotient here is going to be 66. However, you got to think about the signs. There is 1 negative in the problem, or the opposite. So we have the opposite of the quotient, or negative 66. Let's move on to questions 9 through 12, where we're going to actually go ahead and find the average of some different temperatures. So average, another word for that, in case you are wondering, is mean. So to find the average of a set of numbers, we're going to go ahead and add up all the numbers and then divide by how many numbers there are. If we end up with a decimal, the directions here do say that we're going to go ahead and round to the nearest hundredths place if we do need to do some rounding. So to 2 decimal place values, we'll have to look at the thousandths place sometimes to round to the hundredths place. Now, I doubt we'll need to actually do any rounding here, just because if you look at the number of data points in each of these sets, or number of temperatures, we really only have 5 or 4 temperatures. So if we divide by 5 or 4, we're not going to be getting very many decimal places. All right, so how are we going to write an expression to represent this? Well, to find the average, what you should go ahead and write down here is we're going to have this negative 18 plus 4 plus 9 plus this negative 7 plus 0. Okay, so we're going to add up each of those 5 temperatures, and then we're going to go ahead and divide that by 5. So this would be the expression you would write whenever you're finding the average or the mean of a set of data points, or in this case, temperatures. So what we're going to go ahead and do here is, let's add these together. So negative 18 plus 4 is going to be negative 14, right? Now negative 14 plus 9 is going to end up being negative 5. Negative 5 plus negative 7 is going to be negative 12. And negative 12 plus 0 is still going to be negative 12. So the sum of all the temperatures here is negative 12, but we have to split that evenly amongst these 5 different values here, right? So let's go ahead and do negative 12 divided by 5. So let's go ahead and see what this division is going to look like. So let's go ahead and do the 12 inside. Go ahead and ignore the negative sign for now. Take the absolute value if you want to think about it that way. Now 5 into 12 is going to be 2 times. 2 times 5 is 10. And we're going to get a remainder here of 2. Now, if you have no more numbers to bring down, this is what you're going to do. Ready? We're going to take this 12 and make it 12.0 because it's still the value of 12, even if you add that point and 0. But let's go ahead and put a decimal up here in our quotient as well. And if we go ahead and bring down the 0 here and repeat the process, 5 into 20 is going to be 4. So 4 times 5 is 20. So we can see that 5 goes into 12 2.4 times here. All right. So if we go ahead and write what's the average temperature, if we go ahead and calculate this, it's going to be negative 2.4, just because we had a negative divided by a positive. And so going ahead and just summarizing this, we can say the average temperature here would be negative 2.4 degrees between these 5 temperatures. All right, number 10, let's go ahead and just follow the same process. We have negative 8 degrees plus this negative 13 degrees plus negative 7 degrees. So it looks like we have a bunch of negative temperatures plus this negative 17 degrees. So all right, now keep in mind that if we're taking the average of 4 different negative temperatures, we should get a negative temperature here, right? You can't take the average of 4 negative numbers and somehow get a positive number. That would be very strange, right? So let's go ahead and add these up. So negative 8 plus negative 13 is going to be negative 21. Negative 21 plus negative 7 is negative 28. And negative 28 plus negative 17 is going to be negative 45. So let's have a total negative temperatures, add it all up to be negative 45 degrees. Now, if we want to find the average, we should split the negative 45 degrees amongst 4 equal parts and distribute it evenly. So let's go ahead and do the division here. So take the absolute values of the numbers, 45 and 4. 4 is going to fit into 4 one time. 1 times 4 is 4. We're going to get no remainder. If we bring down this 4 fits into 5 one time. 1 times 4 is 4. We get a remainder of 1. Now, just like in the last example, we need some decimals here. So let's go ahead and put a decimal, and a 0. We can go ahead and extend this line as well. If we bring down the 0 here, this is going to be 10. Now 4 into 10 is going to be what, 2 times? So 2 times 4 is going to be 8. I'm running out of room here, so let's go ahead and move this and make it a little smaller. All right. And 10 minus this 8 is going to be 2, right? So I'll put a 2 here. And if you still have a remainder, that's fine, right? You can just take another 0 out here because that 45.00 is still just 45. And 4 into 20 is going to be 5 times. 5 times 4 is 20. You can see we have a remainder of 0 here. All right, so that would be the calculations you would go ahead and write. And we go ahead and say that this right here would be negative 11.25 degrees. So between these 4 negative temperatures, the average would be negative 11.25 degrees Fahrenheit. All right, let's check out number 11. For number 11, looks like we have 5 different temperatures here. Let's go ahead and just write an expression to find the average or the mean, which is we're going to find the sum of all the temperatures. So 39 plus negative 25 plus this 19 plus negative 42 plus 24. Let's go ahead and take these different 5 temperatures. We're adding them all up and we're dividing them by 5. All right, so we know the divisor is going to be 5 here. So when we divide, it should be pretty nice. Okay. Let's go ahead and find the sum of the temperatures. So 39 plus negative 25, that is going to be 14 degrees. 14 plus 19 is going to be 33. 33 plus negative 44 is going to be negative 9. And negative 9 plus 24 is going to be 15. So I think if you add these all up, we're going to get 15 degrees, but we're going to divide that by 5. I don't think we need any standard algorithm here because 15 divided by 5 is just equal to 3. It's a nice whole number here. That being said, we can say the average temperature here is 3 degrees Celsius. For number 12, we have 4 different temperatures here. So we have 9 degrees plus this negative 12 degrees plus this negative 35 degrees plus 24 degrees. So we'll go ahead and find the sum of all those temperatures and then divide it between 4. So we know our divisor is 4 here, but let's go ahead and find the dividend. So 9 plus negative 12 is going to be negative 3. Negative 3 plus negative 35 is negative 38. Negative 38 plus 24 is going to be negative 14. So we're looking at negative 14 degrees here. All right. And so we can see that we're just going to be dividing 14 by 4 here. So let's go ahead and do that. We'll take this 14 and see how many times 4 fits into it. So 4 into 1 doesn't fit, so 4 into 14. Let's go with 3 times 4. That's going to be 12. We're going to have a remainder of 2. Now, what do you do in this case? Well, we could use fractions, but we've been just using decimal so far. Let's go ahead and put a decimal, decimal, and a 0, and bring down this 0 and just repeat the process. So 4 into 20 is 5 times. That's not too bad, right? Because we just had to have one decimal place. So we actually didn't have to do any rounding here. So that was just in case. Let's see, this negative divided by positive is going to be a negative. So we're looking at negative 3.5. So the average of these four temperatures would be negative 3.5 degrees Fahrenheit. All right, let's try just a couple more here. For numbers 13 and 14, let's just go ahead and apply our understandings of integers to reason through each of the following prompts here. All right, so in number 13, it says if m and n are both integers, so just keep in mind that integers can't be any fractions or decimals, okay? We're gonna go ahead and write all the factor pairs that m and n can be so that their product is 24. So here's how I'm gonna set it up, but everyone could set it up a little bit differently. But here's what I'm going to do. So I'm going to go ahead and just set up a table here of our values of m and maybe our values of n. And I'm going to go ahead and put my pairs in like this to show what relationships they could be here. So I think m could be 1 and n could be 24. So those would be two integers and their product would be 24, right? I could also say that m could be 2 and n could be 12, and that would still get you 24. M could be 3 and n could be 8, which also gets you 24. M could be 4 and n could be 6, and that would get us 24. Now, while we do have the same factor pairs here, we could actually keep going here and say, well, what about if m was 24 and n was 1, right? Those would be different values for m and n. We could swap the others as well and say 12 and 2, 8 and 3, 6 and 4. All right, so that would be definitely a way you could write all the values of m and n here. But what you also want to think about is that you also can have these negative versions as well, right? So if we know that the factor pairs have to multiply to get to positive 24, then actually you can have these other factors as well. So sometimes we just think about factors as being positive numbers, but now that you know a little bit more about negative numbers and how integer and their rules work, you want to keep in mind that two negatives multiply to get positives as well. So if you're wondering how many factor pairs there are for m and n that make the product of 24, we have 1, 2, 3, 4, 5, 6, 7, 8, and it looks like we have 8 more over here as well. So as long as we're staying in the world of integers here, we can say that we would have 16 unique pairs of integers that would have the product of positive 24. All right, in question 14, the directions say, regarding question 13, the one we just talked about, explain why the same directions could not be given if we change the word from product to quotient, right? So if we take a look at number 13, we see this word product. Product means we are multiplying. So they're saying, what if we go ahead and change the word from product to quotient? What is the difference here? That would mean that we are dividing instead. So let's go ahead and just start making a list of pairs of integers that would have a quotient of positive 24 and see what's going to happen. So maybe you can figure out why this would not be something that they would ask or I would ask here. So let's see, two numbers that would divide to get to 24. Let's see, we could do 24 and 1 because 24 divided by 1 would be 24, right? You could also say something like negative 24 divided by negative 1. That would also get you positive 24. Could we say something like, though, we could have 48 divided by 2? Well, yeah, that would be 24. Could we also say something like negative 48 divided by negative 2? Sure, that would also get you this positive 24. To get 24, if we have a third 24, that would be what, 72? So we could say positive 72 and positive 3. If you divide those, you would get 24, right? Or we could say negative 72 and negative 3. That would also divide you to get positive 24. If we then went another 24, that would be what, 96? So 96 divided by 4 is 24, but also negative 96 divided by negative 4 would be positive 24. I'll do one more pair here, I guess, or similar pair of 120 divided by 5, that is 24. And one more for good measure, we have negative 120 divided by negative 5, that would also get you this positive 24. So what do you notice about this list here? What do you think is going to happen? Like, why wouldn't we change the directions from product to quotient? If you want to pause and think about it a little more, feel free to do so. But really, if you think about it, we could come up with an infinite number of pairs of numbers that would give you a quotient of positive 24. So when we take a look at pairs of integers on the question 13 here, that the product is 24. There's a finite list of values or pairs that will get you 24. If you open it up to all rational numbers like fractions and decimals, there obviously is a lot more combinations if you are allowed to use those. If you take a look here and you're finding the quotient of these numbers, there's an infinite number of pairs that we could write that will divide to get you 24. It's a little different than factors because we're really maybe exploring multiples of 24 instead, and multiples of 24 will go up infinitely or down infinitely. So putting this all together, is that first we wouldn't divide factor pairs to get a quotient, so that wouldn't really make sense. You take a dividend and a divisor to get a quotient, you don't divide factors to get quotients. And secondly, when you do come up with pairs of numbers that actually divide or find a quotient of positive 24, you can't actually list all of them because there would be an infinite number of pairs of integers that would divide to get positive 24. All right, so there you have a few different practice problems dealing with some multiplying and dividing of integers and some rational numbers. Hopefully you found the video helpful, and if you did, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.